Alright, we have here a problem that deals again with the double slit experiment. Here are the following given. The wavelength of the light is around 610 nanometers. The distance from from the slit to the screen is 2.7 meters, and the distance between um, a bunch of bright fringes is around 22 millimeters. Okay. For the first question here, you're asked what is meant by coherent. Now, coherent is actually uh, having a constant phase difference. Now, what does it mean? It means that in order for you to for the light to generate that interference pattern that we're looking for, both of the source of the light or both of the waves should be having a constant phase difference. It doesn't mean that their phase difference should be zero or their phase difference should be 180 or whatever it is, but it just needs to be constant. As long as they're constant, you would generate that interference pattern that you are looking for. Okay, that's what coherent means. Now on to the next question. It says here, state the phase difference between the waves meeting at Q. If you go back to the image, you have here P and Q. Q is at bright fringe, P is at the dark fringe. Okay, so what are the indications of that? Okay, all right, so it says here you need to state the phase difference. So if it's a bright fringe, that only indicates that you are either at 360 degrees phase difference or 0 degrees. Either way, that would generate a bright fringe. Now, in terms of P, which is a dark fringe, what now will be the path difference? So, most likely it's going to be one full wavelength and a half. So, I would just go with 1.5 lambda. That is equal to 1.5 multiplied by 610 nanometer. Okay, so 1.5 times 610, that gives you 915 nanometers. So this is now your answer for the path difference. Now for the last one, you are asked to solve for A, the slit difference, the slit distance. Okay, so we all know the equation lambda equals to AX over D. Now the thing is, we already have the wavelength, 610. Distance is 2.7. This is what we're looking for. We don't have this. What we do have though is a distance between all the multiple fringes. Now if we go back here, okay, 22 millimeters is from bright fringe to bright fringe, but not just a single fringe separation. We have multiple ones. How many in total? So remember that X is a distance between fringes. So it's either bright, bright or dark, dark. In this case, we're going to use bright. So that's bright number 1, number 2, number 3, number 4. Therefore, 22 millimeters should be divided by 4 in order for you to get X. So let's go back here. X equals to 22 millimeters, or let's just use it in meters already, divided by 2. That gives you 22 times 10 negative 3 divided by, 2, sorry, should be 4, divided by 4. Okay? And you will get 5.5 times 10 to the negative 3 meters. Okay, use this in your equation. Now that gives you A equals to lambda D over X. 610 times 10 to the negative 9 multiplied by 2.7 all over 5.5 times 10 to the negative 3. Let's compute. 610 times 10 to the negative 9 times 2.7 divided by 5.5 times 10 to the negative 3. That would yield you 3.0 times 10 to the negative 4. So this is now your answer for your question.